Welcome to Lesson 17. In this episode, I want to show you how to use a dummy block with Analyzer Manufacturing. Let's assume we have a bench top with an upstand, and you want to cut a groove on the underside of the bench top. I've already applied all the part properties, and this one is a machine block for the groove. Here's a machine block I've already assigned to an assembly. Let's put that into Analyzer Manufacturing. We assign a job number and a work order number. Next, we run the geometry script. As you can see, we now have the cutout, and for the machine block, it created a second program. Let's export this to Analyzer CAD. We run the translator script so you're running two sets, which means a second program. Now let's select the parts. We've got our plywood panel here, and we also have a second program. As you can see, two programs were created. One cuts the cutout from the top surface, and the other does the groove on the bottom. Now we want to combine this into one process. Having two operations is inefficient because you'd need to cut out, then run a second program, flip the panel, and machine again. Instead, you can force Analyzer Manufacturing to run both at once. So rather than machining from the primary face, we'll switch to the secondary face, including the cutout in this case. Why did Analyzer Manufacturing choose the top face? Because it works off the centroid of the assembly. The centroid is the center of gravity, so to speak, of the assembly's boundary. Here, the assembly matches the benchtop's length and depth. In height, we have the upstand, so the total boundary is the upstand's top surface plus the benchtop surface. That's the outline, so the centroid ends up higher than the benchtop surface. Analyzer Manufacturing then uses this centroid to decide which faces require machining. It works from the centroid outwards, up or down, until it finds the first available surface. That surface becomes the part's primary face, in this case, the top of the bench top. Now, centroid logic makes sense for a cupboard since most machining occurs on inside surfaces. But here it's different. We want Analyzer Manufacturing to treat the underside of the bench top as the primary face. To do that, we draw a dummy block. The size doesn't matter much, only that it's correct. The upstand is 50 millimeters, so we'll make the block 60. This way, when Analyzer calculates the centroid, it considers the upstand's top and the dummy block's underside, pulling the centroid down past the benchtop's underside. Next, we assign part properties to the dummy block. We'll analyze the CAD part properties and call it dummy. For material, we'll also use dummy. Then we assign it to the correct assembly. In User 2, we type no CNC. This ensures no macros run for it. We save, and now the dummy material is automatically excluded from the cutting list, so there's no risk of it appearing there. We'll call it job number 333 and work order number 42. We run the geometry script. As you can see, it flips the panel and applies the machine block to the underside while cutting the cutout at the same time. Now we export this to Analyzer Cam. We select Panel Optimizer, then Analyzer Parts. We go to work order 42, which shows our first program. In optimization, here's our optimized program. As you can see, everything is combined into a single process. We have the cutout and the groove on the bottom, with the panel flipped for underside machining. That's exactly what we wanted, all in one process. That concludes lesson 17. Thank you very much for watching.